Hey team, hi, good evening. It's Tuesday again, and again we are here with the code part, the art of deployment. So today we'll be talking about the same, the art of deployment. Now, till now, as we always discuss, till now, what we do is we loaded the library, we cleaned the data, we did auto EDA, right? We visualize the numerical features, we visualize those columns, we saw, of course, box plot we saw because there were outliers, and then we removed those outliers. We did data pre-processing, we did model building and evaluation. Later, we got to know, okay, we have the model and accuracy can be increased. Now, how accuracy can be increased of a model? We can do hyperparameter tuning after that, we saw. Okay, so hyperparameter tuning we are doing. After hyperparameter tuning, in that what we did, we defined perform grid search using grid search CV. Grid search CV is just cross validation. Now after that, we talked about perform grid search for each model. We said we use the same function for each and every model, and we fitted data. In that, after that, we evaluated the best model using train and evaluate. Train and evaluate is again one of the function that we made. Again, it's a custom built function, right? After this, we talked about evaluating best models, and we got the result. Again, we're talking about accuracy. We talked about accuracy, its precision, recall, up and score, all those things. What we got to know before this, that all these models are working really good. And random forest, the tuned random forest that we got after hyperparameter tuning is giving the best result. So we said that, okay, we will continue with the same. So we said that, okay, if the F1 score we have, it's balancing both precision and recall. And random forest has the highest F1 score, accuracy, and relatively high recall. So we tuned the random forest model is likely to, so the tuned random forest model was likely to be the best choice amongst the three. So that is the sole reason we went for this tuned random forest. Now what we did, we used pickle. Last time we imported pickle. Of course, I made some changes to this. We made pickle and we dumped it. Pickle.dump, and we chose random forest.pkl, and we wrote binary. WB is just write binary. When we did that, we saved that random forest model. Now, last time we saw what is the difference between joblib and pickle, right? If it's a simple file, we can go for pickle. If it's a bit complex one, we can go for joblib. So pickle we use here, pickle.dump, best random forest, open random forest pkl.wb was done. And then we opened the same model, we loaded the same model, and we predicted on X test. Right. Now, here, after that, we said, okay, let's test the pipeline first. We generated a test data to test in deployment. Number of rows to sample n equal to 25. We selected random rows. We say that, okay, random sample equal to data dot drop, income x is equal to 1, sample r n equal to n, and random state equal to 42. Now, we said that if random sample, random state is 42, this means we need to use the same state. We need to use the same data that is made here. Once we make it, we will be using it again and again. So we said, okay. And then we saved a random sample to CSV, and we made it test income.csv. Let's run this. Right, now we need to run this file. We'll of course run this file. Okay, we ran this file. So test underscore income.csv is ready. So we'll see this in, and for example, here we have test income file ready. Right, this is the test income file that we are getting now. Now what will we do? Here we will load all the saved file first. We need to check it, right? So what we'll do, we'll say, okay, load all saved files. So we'll load all the saved file. First of all, we'll call pre-processing and we'll say pre-processing, of course. Pre-processing, we say pre-processing equal to joblib dot load, and then of course we need to take pre-processing.pkl file. Now understand, this is joblib.load. Okay, I'll just make sure that I create an error and then I'll clear it. Okay, we call it pre-processing and we say windsor. Of course, we have seen we have done winsorization. Again, joblib dot load. In bracket, of course, we have windsor. Right, windsor, and then again we say we have model equal to pickle dot load. We say okay, open. Now see this, we are using both pickle and open. We'll say this is random forest dot pkl. It's a pkl file, right? Pickle file we call it, and comma rb. Now what is rb here? Rb, when we say, is read binary. Whenever we open a file, remember during your class, during your regular session, when we were talking about file handling and exception handling, in file handling topic, we talked about how to open a file. So when we talk about opening a file, we say there are different commands, right? There are different modes. When we give open command, there are two things. First is a file name, and second, when you write comma, and there is mode. Now there are different modes we have. First is WB. For W, basically there's W, R, and there is A and X. When we say W, W is just write binary. What it does, whatever is written there, it just cleans that and then writes whatever is needed. If you don't have a file, it will create a new file and it will continue. RB is read binary. R is basically to read the file. Whatever is given in that file, it will just read that. And we have, for example, the third one is A. A we have to append. We use A to append, and append means whatever is written there already, we are using that and taking that particular file and adding whatever we want to add. That is append. Now, after that, we have the fourth one, that is X. We create a new file there. Now, four things is WB, that is W, that is write. Then we have R, that is read. We have X, that is create, and A, that is append. Right. I hope this is clear. If you don't remember, let me just write it first for you, and then it will be very clear for you. So we have W. Okay, whenever we open a file, whenever we give open function, we give file name, comma, the mode. We have this open function we give file name and mode. So this is file name and this is mode. So when we are saying file name and mode, when we say, there are four different modes. There's R, There's W, there's A, and then there's X. R is basically read, W is to write, A is to append, X is to create. Read the file, whatever content we have. Write. What read does? Of course, reads each line of file. Write clears previously written content and writes again. Append just adds to whatever content we had. And create, X is creates a new file. This is the basic of it. Now, you need to understand when we are talking about pickle or joblib, whenever we are saying pickle, we are saying WB. Whenever we are saving the file, WB full form is write binary, and then we have RB when we are opening the file, or I should say loading the file. RB is just read binary. Right. I hope this concept is very, very clear for you. Now, let me clear this and let's continue with our discussion. Continue with our code. Now, if we load all the save files, it will throw error. So it is saying there's no file called pre-processing. Why we don't have a file called pre-processing? Because when we are loading it, we say preprocessing.pkl. Remember, whenever you are loading the pickle file, you just give the extension of save. Right? Pre-processing. Okay, sorry, it should be pre-processing. Preprocessing.pkl. Yes, it's done now. Let's create the outlier column list here first. To create outlier column list, that is, we have age, we have final weight, we have education dot num, that is hours dot per dot week. Right. We will just say these are the outlier column. Oh, so sorry. It was outlier underscore column underscore list, right? Can't give it as should be outlier underscore column underscore list. It's a variable name and we gave space, so that was a problem. Now, of course, that is in the variable description rule. Now, let's add all the cleaning steps here. Let's add all the cleaning step. Let's define a new function. We are saying predict income. And of course, you have data. Clean equal to data dot replace what we want to replace there and what we want to replace it with. Now, for example, in the data, if we see, there must be NaN. Basically, null values we are talking about. Okay, just a minute. Let me make a square bracket. Let's see. Of course, we have NaN and we have Na. So sorry. We have Na in oblique A. We have in dot A. We have n hash A. We have n hash A again. And we have question mark. So out of all these things, we take these brackets, whatever value we had like this, and we are saying replace it with the term other. Right. Now, let's do the outlier treatment first. There was a problem with my mic. So yes, pd.data frame. Of course, let's continue with the same pd.data frame. And yes, we continue. Model, prediction pd.data frame, model.predict. Of course, we are just predicting the model in order to predict. And what are we predicting on? We'll say pre-processed, process, comma, columns, and we're talking about zero value. Yes. Columns equal to, of course, we need to talk about spread underscore income. That is predicted underscore income. Right. Now, let's talk about it further. We say prediction and we say predict underscore predict underscore income. Of course, we're just talking the same thing. Talking about particular column. So spread underscore income equal to prediction spread underscore income dot apply, and we will use a lambda function here. Lambda of x colon, if it's greater than 50k, so if it's greater than 50k, if x is equal to 1, else we say it is less than 50k. Right. And then we say final underscore data equal to pd.concat and bracket the prediction comma data comma x is equal to 1. When you say x is equal to 1, we are talking about column. Right? Of course, we will write it properly. And we say return final underscore data. Return final underscore data. Now, let's just run this. I guess there was some issue, some inactivity, and yes, this line has run now. Now, what will we do? We'll just test the same. We have made a predict income for function. We'll see test underscore data first equal to pd dot read underscore csv. Since it is in same folder, we are not worrying about it. What was the name here? Say test income dot csv, control C. We're using the same name here. Control V, test income dot csv, and we'll say test underscore data dot head. Of course, you get the top five rows. Let's just run this. And yes, we are getting this the result. Now we'll predict it. I understand just 1 minute is remaining, but yes, let's complete this file. Elections. We're just testing it. Predict underscore income. When we do that, we say predict it on test data. This underscore data. Right. Let's just predictions. We are saying predictions on the red dot income. Red underscore income. And we will predict that. So yes, we have predicted if it's less than 50K or more than 50K. So from next time, in the next episode, it's already 6 p.m. So in the next episode, we'll continue with the same portion, deployment portion. We'll deploy our model on Streamlit now. We have everything ready. So yes, team, I hope you enjoyed today's session. We'll continue tomorrow. Not tomorrow, of course, next Tuesday. And yes, we'll rock it again. So till that time, please subscribe to our YouTube channel. And yes, enjoy your evening, team. We'll meet next week for sure. Till that time, happy learning, team. Take care.